Okay, so I think we can start the course. In this week, we will talk about the light, okay? The lighting model. We don't have too much left, so we can, if we do it hurriedly, quick enough, we can even finish in this week. But since we have enough time, I will give you some additional calls about some other topic, okay? Uh, yeah. So let's start this week's course. Let's have a quick week about the lighting. Shade, yeah. So when we talk about the modern real-time rendering, there's a concept or theory which you might heard quite often. That is physics-based rendering. So physics-based rendering is very useful. It is first proposed by Walt Disney Studio. Uh, they have the artists there and they have scientists. First, they gives out this research about physics-based rendering, and they provide a model. So, physics-based rendering actually is about how we simulate world. Uh, in order to get the physics rendering, we should think of something like the lighting, the camera, the material. Okay, at least three parts. But now in most time, when we refer to physics-based rendering, we just talk about the material. But just bear in mind, physics-based rendering actually has three parts. Okay, we have seen how to simulate the camera, but now we will see what about the lighting. Okay, so in terms of lighting, there are two parts. The first part is direct lighting, and the second part is indirect lighting, and which is also called the global illumination. Okay, so if you hear the word global illumination or GR, actually it means the indirect lighting. So first, let's look at what is direct lighting. So when we talk about direct lighting, there's a word shading. Shading is the key to direct lighting. Okay, so the pixel value is computed by a shading model. Or if we look at the model, or if we look at any object, the brightness of the object is shading. Okay, so there are several parameters which might affect the shading of the object. The first is the light direction, surface normal, and view direction. All these three are the fundamental part for shading. Okay, so first let's look at some simple direct shading model. The first one, okay, so let's first look at this picture first. This is more like some roughness image, right? This one is we added with ambient light and shadow, right? This is the final one, which we rendered it with the specular part. So with these three, we can get a realistic static image. So roughness, ambient and shadow, specular. So how we add from here to here. So let's look at this part, roughness first. In roughness, what we use is a diffuse model or Lambertian model. Okay, so what is diffuse model? Diffuse model suppose the object is roughness enough that the light only decided by the brightness or shading only decided by the angle of the surface to the light. So we can often see this kind of object. For example, your clothes, especially some woolen or cotton clothes. If you look at the clothes, you will see it has some brightness changing, right? And all this brightness is caused by the angle of surface to the light. So if you just find out the light source in your room, maybe it's a light or maybe there's a window, and just see your clothes and see the part which is brighter, and you will see it might be possible it is facing towards the light. Okay, so this is the diffuse model or the Lambertian shading. If we use a mathematical equation to describe it, it can be described by this. It's a max function of 0 and the surface normal dot product the light source direction. Okay, so this is the angle of the surface to the light. If they're clear enough, close enough, this value is 1, so it means very bright. If they're nearly perpendicular to each other, or the degree is almost 90 degrees, this is 0, so it means very dark. The reason we use the max function because we want to get the value of the brightness, and the brightness should be bigger than 0, so it's a positive number. If it's negative, it doesn't exist, right? Because maybe only the black hole it can absorb the light, but in the world, in normal world, I mean in the realistic, not realistic, but the in our lifetime experience, 0 means dark. Okay, so we get the max function to get the bigger part of this two, and we times the light intensity. So this is the light intensity, or maybe light color, and there's a coefficient. This coefficient is called the diffuse term, and actually the diffuse term is kind of complex. Okay, actually this term is kind of complex. Okay, so this is Lambertian shading. To extend the shading model to with the specular part, Blin and Feng proposed this model, which is also called Blin-Feng shading. The Blin-Feng shading takes the specular part into consideration as well as the diffuse model, or as well as the Lambertian part. So the key is how to calculate the specular reflection. I think you might have some experience like using mirror to reflect the light, right? If you have very shiny objects, you can reflect the light source just using this shiny object, maybe like a mirror. Okay, so this is the mathematical way to describe it. I mean, This is light source, right? This light source direction. This is surface normal. There is a reflection angle. The reflection angle is here. If your eyes or your view direction is more close to this reflection angle, you might see a very bright area. But if you leave this direction a little bit, you will see the shading drops greatly or quickly. And this is called the reflection lobe. If you see some research paper or some other technical books, this area is called the lobe or reflection lobe. Okay? And to describe this function, we use another direction which called the half angle. Half angle is so often used in a lot of area. Okay, so half angle is the angle between light direction and view direction. And we calculate the half angle using this mathematical form. Okay, so the principle is quite easy because these are all normalized vector. So if we add them together, this is a diamond shape. Okay, and this diagonal is actually the middle of these two angles. And we normalize it to get the h direction. And h direction is often called the half angle or half angle direction. Then we just measure the distance between or as the angle between surface normal to this half angle. Okay, and you will see this is equation for the specular part. As the lights, we take the max value of 0 and this cosine value. Since it is specular, the light drops greatly, so there is a power function here. We have the light source here, which means the light intensity, and a coefficient to represent the specular part. Usually this is more like 1 in most situations. Okay, so this is the diffuse term or Lambertian term and specular term. We add them together, and this is plane form shading. So there is another term called ambient shading. It is because if we see an object, right, you might see if we just apply this function, there will be no lighting or no shading behind the light. Okay, so if this is the surface normal is to this light source and to this half angle, the angle between the surface normal to these two vectors are bigger than 90 degrees, there should be no lighting. But this is not true in real world because we might have some reflections, right? And we call this the ambient lighting. So we can add the ambient lighting, diffuse, and specular together to get the general lighting model. And for multiple point lights, we can sum them together. Because this is just one point light, one light source. So if we have several light sources, we add them together. Okay. So this is ray tracing about to calculate the shadow, but we don't talk about it. We just give you a brief idea about how to use the ray tracing to get the shadow. It's like this is a screen we look at. We just create a vector, or using the light direction, we add from the screen pixel and add this and calculate. If it hits something, it means this is a shadow because it is occluded by this object. If it doesn't hit anything, it means okay, this is not shadow. This is a way to calculate shadow by using ray tracing, but we won't cover too much about it because in modern world we don't use this method to calculate the shading. Okay, so this is just the lighting model. We are trying to simulate this thing in our code. So in order to simulate to implement it, we need to create a light source. We need to have the surface normal, and we also need to have the view direction. Okay, so those three things is what we need to implement. So let's go back to our code and see how we did it. Okay, so there are 12 students now. So first, let's create a light. We will create a small cube, and the cube is rotating around our cube. So first, let's look at our cube. This is our cube, right? We will create a small cube which rotate around our cube. And then we use that to simulate light. So let's new a file. Actually, this might not be a neat file, but it's a simple way. Let's create something called light. Okay, so this is a light. And let's include the light first, just in case. Okay, so let's implement the light. Let me see if I used this before. Okay, let's keep this frame, keep this framework, and do all the coding within it. So we use this. So first, let's add one header file which we needed. We should have GL. That's the header file we should. Then let's go back to our code and have this cube, okay? Because we want to have a cube. We just use this cube, but we use a white cube to represent light. So use the Option key to just cover all this bit. This is our light. And we call it, oh, sorry, one more minute. It's a very long. Not long enough. And we call it light vertex. So we just copy the position of the cube and put it here and call it light vertex. Okay. We need a white one. The simplest way to do it is using the Alt key. Okay. Then we can create a class called light. It has some public and private. Okay. So for public, we have the constructor, which is light. And we implement here. Here we draw some idea from a lot of area. We can create an update function, which called or local function. We don't have a light, but don't worry. And we will have something called void draw, a draw function. To get its address. In private, we have two. Actually, we are drawing this box, and we have the shader. No, we don't have shader, but we try to quickly do something. And now we have this updating function. Okay. So first thing for the draw is simple. We just copy the code here about how we draw these things. Okay. We bind with AO, and we draw, and we unbind it. So just 3 lines of code. So this line of code first. The night. So this is this video. And in camera, there's draws, triangle, and unbind it. So this is draw. So next time we can create a light and say light.draw, then we can draw the light. Then we try to implement the update. Update actually is this part. It's we create video and bind and do all the settings and unbind it. So let's just copy all these things until here. Or we might modify this bit a little bit. And also want these 2 lines of code. So just this bit. Actually, we create a class to do all these steps. And we change this to be this video. And also, yeah, a lot of this. This video, this video, this video. And this light, since we have a light vertex. Now we have 3. So actually, we just modify that part. I mean, we can just do using this to do a lot of things. So this is a light. Very simple and neat code. And by using this, we can create a light in a very simple way. Okay, we have 11 students. So I think this is enough for you guys because this is to just copy and paste, right? We just copy this part from here. Actually, it's copy this from here to here. We delete this thing. We just create a local variable or private member function variable for these two. And since we have only the position, this should be changed to 3. Okay? So now we can draw this thing. To draw this thing, before we draw it, we should create a shader. Now we also need to draw the shape. We also need the shader. So for the shader, let's go back to the shader folder and duplicate these two or modify it. When we rename it as light. So light is here. For this light, we don't have color. We don't need to output color. We have this transform, projection, the view. Okay, they're all here. So we just delete a few lines, and that's it. And for the flag, we just draw one color. So we don't have in. We only show the white. This is light vertex shader and light fragment shader. Okay, so let's have a break for 5 minutes. let's come back. Let's quickly draw this shape, this cube. Yeah. So let's see how we do it now. For the shader part, we call it light shader. Rest shaders. Yes. And so these are the shaders. We can just do this. And for the light model, it's even simple. Okay, so let's continue the class. Okay. Okay, so this is light shader. To add the models of the light. Now it's very simple. We can just create a light using this light function. Just by doing this, just one line of code, we can do all these things. Okay. Previously, we have all this. From here, we have the cube. We do all this setting. But now with just this code, we have this light model. Now let's draw it. Now here's the draw loop. First, we create a function, a variable called light pose or light position. It's better this is lowercase. And we create somewhere, maybe here. This is light position. Now let's draw this light first. Okay. Yeah. In order to draw this light, there's one header file we need to edit here, which we should go to the top. So first, this is light position. Because we try to simulate the lighting, right? We try to implement the shading function. We should have the light. That's why we create all these shaders, all these VL and VBO, these models to draw this light. And we should have the light position. In order to implement this, there is one header file let's create here, which is grm gtx rotate. When you run the code, it might give you some warning or some errors if you run the code. There is some solution here. You might need to define something, or maybe define grm experiment or GTX. I'm not quite sure, but when you run the code, if you see some warning or errors in your debugging area, it says, okay, suggests you to do something, and you just do that. Add this line of code, then it works. Okay. It might be there, but it might gone already, because it happens in last year, but then in this year I haven't heard about it. So if you add this and if you see something here when you run the code, just do remember you can follow the instruction and make it work. Okay, so with that header file, okay, then make sure you type it right. The GTX rotate vector. Okay, so here, let's draw this. Let's first go here. Get here. This bit. First, let's cut and paste these two things a little bit up above. Let's cut and paste them here. We want the projection first and the view first, then transform. We change this all these orders. The projection first, view, and then transform. So we move this two variable from here to here. Okay. Now let's draw the light. So first, light pulse equals to, we want the light pulse to rotate. It's rotating all the time. With this line of code, we can make the light pulse to rotate all the time. Here we only have one incremental value, okay? And this light pulse, we don't initialize it all the time, so this incremental value just added all the time. Increase this light pulse frame by frame, okay? And we rotate it. Now the transform equals to GRM translate transform light pulse. Finally, we resize the light. We make it very small. We can directly copy this code and change the value to be very small. So we have a very small cube to represent the light, and we have this light pulse to take a record about where the light is. Okay, so let's draw the light. We should first light shader use. We are using this light, and we parsing all this value. We parsing the view, transform, and projection to our model, which means we can copy this 3 line of code. This is parsing the value, but here is light shader. Finally, we can draw this. This is light. Draw light shader. There is one line of code missing, which is this. We should initialize this transform again after we use it. So here, let's transform again. Initialize it again. And that's the same. Now we can run the code and see if the drawing, or if there's something else we need to change. Yeah, you can see this light is rotating all the time. It rotates quite quick. Let's change the speed a little bit slow. Not 10 times, but a little bit slow. And this direction also need to change a little bit. Let's see if it looks okay. Okay, it's rotating this way. We can modify this value again to make it look better. Okay, here no, there's no change. Yeah, it's possible. Because in this way, that means it's not just rotate by itself. What's this? Yeah, this time it looks better. Okay, so now we finish the lighting. We draw a separate light, which rotates along our cube. With that, we can implement all this lighting or implement some shading model. Okay, so let's go through this code again and see what's going on here. First, we have seen the theory about the lighting, right? There are some shading models. Very simple shading model is Lambertian model and the Blink-Phone model. Lambertian model is just the diffuse model, and Blink-Phone model is the Lambertian plus specular. So in order to implement this shading, we should create a light or a light source. We create a little cube to represent the light. We have already seen our code about how to draw a cube. In order to draw a cube, we should have this shader function, the vertex shader and fragment shader. We should have all this data, and we should have this VAO and the VBO to set up or configure this shader. And we also need to have some function called draw to bind the VAO and the draw. But if we write them again, the code will become very long. So in order to do that, we create a light class. So to draw the light, we should have this VAO and VBO setting for light, and the vertex, and also the shaders for the light. The shaders for the light is very simple. We just draw the cube. The cube is moving all the time, and this is white, so there's no color. No other colors at all. I only have a white color, and only have this changing of the model. Okay, it only has the projection view and transform. And for the light class, it has this cube. Okay, all the vertices about the cube is listed here. And this class have a constructor and a draw function. A draw function is to implement how we draw something, which means the draw function just implements this 3 lines of code. This, this and this. And this draw function, and okay. This update, the constructor is update. The update is responsible for buffering this data to the graphic card and explain them. How we explain them, how we make a local index about how to use them. We use will view. We copy a lot of code from here, right? This is we have the cube, and we buffer the data to the graphic memory and configure this or doing the setup here. We did all this thing here. So this is the light function, or the update, a private light update function in this light class. Now, if we want to draw it, draw the cube. First, we create this shader, and we set up the light. This means this. To draw it, we just use this draw directly. But before we draw, we should also send all this value to the shader. So that's why we shade the transform, projection, the view to this light shader. Because we need to find this variable in the light shader. Make sure you didn't type it wrong. If you type something wrong here, you will have some zero matrix, then you will have nothing. Okay? So it's possible, just make sure you type all these things right. And to do this, we have the light position. The reason we have the light source is we want to take a record about the light position. We create the light position, and projection view is simple. We have touched them before, but here is transform. Transform means, okay, each time we operate on this light position. So now we know the light position is rotating all the time. Then we translate the transform matrix to this light position. So this transform, by applying this transform, we can rotate our light to here. After sending all this data, we can draw. And we rotate, we translate, scale, all this, just make it familiar with everything. Okay, so here is a way about how we implement light. Next time, we will just implement the lighting function. The way to implement lighting function is actually implement something here and here. They are all here. So you will see, if you want to implement a lot of effects, visual effects in computer graphics, all your work is working on vertex shader and fragment shader. Okay. There are only one few things is we need to add some normals here, but we will touch it later. With normal, surface, view direction, and the light direction, we implement everything here and here. And we can create an object which to simulate a lot of material. Okay, so I will leave the code here. Let me know if you have any doubts.